Welcome to the video, another video. It's about secondary battery. In the previous video, we have discussed about primary batteries. In this video, we are going to discuss about secondary batteries. These secondary batteries are the batteries which can be rechargeable. That means we can reuse it again. Coming to the example, lithium ion battery is the example for secondary battery. As usual, all the cells will have anode, cathode and electrolyte. Here, lithiated graphite rod will act as anode and cathode, cobalt oxide will act as cathode. This cobalt oxide will have pores to embed the lithium. And here, instead of all the inorganic solvents, one organic solvent is used, because if we use inorganic solvent, that lithium vigorously react with that inorganic solvent. So to avoid this, organic solvent like ethylene carbonate is used. Next, coming to the construction, lithiated graphite rod. That means graphite rod is coated or like embedded with lithium ions. It has pores. In that pores, lithium is embedded. And at cathode, cobalt oxide, which is also having pores. This is cathode and this is anode. And we have semi-permeable membrane in between. This semi-permeable membrane, generally we are going to take a polymer to allow flow of ions from anode to cathode and cathode to anode. The purpose of this semi-permeable membrane is to allow ions from anode to cathode and cathode to anode. This polymer like sulfonated Teflon will be taken as semi-permeable membrane to allow the electrons passage from anode to cathode and cathode to anode. Now coming to the working. Lithiated graphite rod undergoes oxidation and it gives lithium ion. And at cathode, this cobalt oxide takes that lithium ion and it gives lithiated cobalt oxide. This reaction occurs at anode and this reaction occurs at cathode. So, if we are using the energy from the cell, like means discharging, energy is discharging from the cell. What type of changes occurs here? Lithium ion moves from anode to cathode and also electrons. Lithium ion and electrons moves from anode to cathode. Now during charging, that means if we connect this battery to the external energy supply, externally energy supplying to the battery, then lithium ions and electrons flow from cathode to anode. This is discharging, this is during charging. That means coming to the overall reaction, lithiated graphite rod and cobalt oxide gives graphite rod and lithium cobalt oxide. This is reversible reaction. During discharging, forward reaction takes place. During charging, backward reaction takes place. That means during discharging, if you are connected this battery to your phone or your something toy, that lithiated graphite rod reacts with cobalt oxide and it gives graphite rod and lithium cobalt oxide. And if we consumes the energy coming out from the battery, then we are going to recharge it again. That means we are going to supply external energy to that battery. During this external energy supplying, this lithium cobalt oxide reacts with graphite and it gives cobalt oxide and lithiated graphite rod. Again, products convert as reactants, and during discharging, reactant will convert to product. Applications. Applications of lithium ion battery. These are used in smartphones, laptops, e-vehicles, cameras. Next, machinery like cutting machinery, saws, drilling machines, etc. Secondary batteries, these are rechargeable batteries. We can recharge again, we can reuse it. Example for the secondary battery is lithium ion battery. Coming to the construction, lithiated graphite rod. That means graphite rod has some porous. In that porous, lithium is embedded. Next, cathode, cobalt oxide will act as cathode. Electrolyte, here organic solvent, we have to take organic solvent instead of inorganic solvents, because this, if we take inorganic solvent, that lithium will vigorously react with that, so that the battery may not work. So that we are taking organic solvent like ethylene carbonate. And these anode and cathode are separated by a semi-permeable membrane. This semi-permeable membrane allows the flow of lithium ions from anode to cathode and cathode to anode. It allows only passage of lithium ions. Here, sulfonated Teflon will act as a polymer. This polymer is taken to allow the flow of lithium ions from anode to cathode and cathode to anode. Next, coming to the working. At anode, lithiated graphite gives graphite and lithium ion. This lithium ion moves towards cathode, and at cathode, this cobalt oxide takes that lithium ions and it is embedded on the pores, and again it converts as lithium cobalt oxide. This reaction occurs during discharging, and during charging, that lithiated cobalt oxide gives the lithium ions, and the lithium ions passes towards anode, and again they are embedded in the graphite rod. This reaction occurs during charging. Coming to the applications, these are used in smartphones, laptops, e-vehicles, cameras, saws, drilling machines, etc. Thank you.